Segment number 7 ended on slide 38, where we were ready to go to outputs 3 and 4 for the random intercept LTA runs. Here is the setup for that RI-LTA run. We take a look at the input instructions and see what's different from before. Well, now we're going to talk about algorithm equals integration here to be able to bring in a factor, a random intercept factor. So we have this situation where we have a continuous latent variable and we have categorical observed variables, and with maximum likelihood estimation that leads to the need for numerical integration. And the default is 15. If you start seeing negative change improvements in the log likelihood over the iterations, then you may have to change it to integration equals 30. But here, since we commented that out, the default of 15 is in operation. And the model statement then adds only one segment here. We measure a factor f by the 5 latent class indicators at time 1, 2, 3, and 4. And we avoid the Mplus default metric setting of fixing the first loading to 1 by having this asterisk that frees them all. And we instead set the metric by choosing factor variance 1 and factor mean 0. And the loadings are held equal across the different time points, P1 to P5, or the 5 loadings for the 5 items at each of the 5 time points, held equal. And that's the only thing that you have to do. And then you're off and running. So let's take a look now at the model warnings and errors. So here we have the list of log likelihood values from our random starts, and we see that they are very much the same, all of them, except they differ in the last decimal here for some of them. But Mplus considers this to be a true replication. Actually, the tolerance is 1 here, so only if it went to 329 or 327, then you would consider it not replicated. Again, we're going to keep an eye on the best opseed here, opseed for the best run, in case we don't like the class reordering. We have the common issue of one or more multinomial loaded parameters fixed to avoid singularity of the information matrix, and here there are a few more than for the regular LTA, and I will return to that in a second. What we really want to take a look at is the latent class indicator means and probabilities for each latent class as a first step to see that we have the classes in the order that we like. And you see here then that this seems to be the medium class, class number 2, and this seems to be class number 3 with high probabilities all the way to the more advanced items, and the third one seems to be class number 1, where the probabilities are lower than for the other 2 classes. So the classes appear in the order 2, 3, 1. So we want to reorder that into having the third one first, so 3, and then 1, and then 2. So we want to do it as 3, 1, 2 in the second run. So let's take a look at that. And that is the reordered run for RI-LTA. And the only change then is that we, instead of starts, we use the opseed that we found in the first run, and we use this reordering 3, 1, 2 for all classes. Now you can go to the model fit information And we're going to compare this to regular LTA in a little bit. And first verify that the order is the right one. So you have class number 1 with low probabilities here for the bottom 3 items. Class number 2, which has a little higher probabilities. And class number 3, which has the highest set of probabilities. So we're able to get that in the right order as we wanted. And we should also check that we have the same log likelihood value as we got in the first run. And Mplus does that automatically, but you may want to check that also. Now, in this case, we get some information of interest that's from the model results, because we already have something in our naturals in a scale that we're used to. We don't have this problem of having to translate to probabilities or odds ratios. And that's the new thing, the factor measured by the different items at the different time points. So you see here they have factor loadings that repeat over the time points. 3.5 comes back here for each new time point. So we have time invariant factor loadings, as is the idea of random intercept factor addition to the LTA. And we see that they're all positive and all significant. And we interpret the factor as a factor that, when it has high values, makes you do better on these items. And some would interpret that as a trait, an individual differences concept, so that some kids are more able to solve these problems than others. Or you can see it as taking out the differences between people so that you can study the differences across time for people in the latent class transitions. Now you can also see this in terms of IRT parameterization. So if you're into item response theory, this is really a item response theory model. And we translate then our loadings and thresholds into item discrimination and difficulty. And the item discrimination here is the same as the loading, because the factor variance is fixed at 1. Whereas the difficulty is the threshold divided by the loading, so they come out this way. So if you prefer that, that's another way of looking at them. Now, 2 technical comments before we take a look at the comparison with the regular LTA. One is this message that we got. We have 1, 2, 3, 4, 5 parameters that got fixed. And that corresponds to what we see in the latent transition table here, or tables. We have 1, 2, 3 exact zeros, 4, and 5. And those are the causes of the fixed C on C slopes. Again, it's totally innocuous, and you can trace them back to these zeros. The fact that no child unlearns or goes back in their development. Now, you will see then that it's actually it refers to C2 number 1 and C1 number 1 and C2 number 2 and C1 number 2. So these two, instead of where the zeros are, and that's a trivial technical matter, where that the lowest row here is where the intercept parameters are estimated, and they are listed in the computer, in the program. They are appearing before the slopes appear. So not until you get to the slopes do you get this indication of needing to fix them, otherwise the information matrix would get singular. So that's why you don't see them in the exact same spots, but you have the same number of them appearing here. That's one technical point, which means that this message can be ignored. It's explainable that way. Now, another thing you might want to take a look at is the Tech 8. So here you have the Tech 8. We did the reordering, so we have two of them actually, but we can look at only one of them. And we see here positive apps changes. We have no problems in monotonically improving the log likelihood, which is a good sign. Sometimes you don't get convergence when you have a lot of large negative apps changes. And again, these two end at the same log likelihood, the reordering as the initial run. Now we go back to model fit here, but let's also bring in a comparison, the regular LTA reordered. So we have that, and we can use this feature of tiling things vertically. So you have them side by side. So on the left you have the regular LTA, and on the right you have the RI-LTA. RI-LTA has 5 more parameters because you have 5 loadings that are held equal. So that's why. And you see that the likelihood is considerably higher. This is less negative than that is. And the BIC is considerably lower, that is better than this. And we're going to make a detailed comparison of the two. You can see that the latent class probabilities are also quite different, and you can see that the measurement probabilities are pretty similar, but the latent transition probabilities, that pattern, is quite different between the two. And we're going to take a look at the details of that and try to understand a little bit more about that.